Lesson: Designing AI-Augmented SOC Architectures. Designing AI-Augmented Security Operations Center architectures involves integrating artificial intelligence technologies into the core of security operations to enhance threat detection, response times, and overall efficiency. As cyber threats become increasingly sophisticated, SOCs must evolve beyond traditional methods, leveraging AI to meet the demands of modern cybersecurity landscapes. This lesson will explore actionable insights and practical tools, frameworks, and step-by-step applications that professionals can implement directly to optimize SOC operations. AI-augmented SOC architectures begin with understanding the role AI can play in enhancing security measures. AI technologies, such as machine learning and big data analytics, allow for the automation of routine tasks, enabling human analysts to focus on complex threat analysis. For instance, machine learning algorithms can sift through vast amounts of data to identify patterns and anomalies indicative of potential security threats. This capability is crucial for threat intelligence, where time-sensitive data must be processed in real time to mitigate risks effectively. A practical approach to integrating AI into SOCs is the deployment of security information and event management systems augmented with AI capabilities. These systems collect and analyze security data from various sources in real time. AI-enhanced SIEMs can automatically prioritize alerts based on risk levels, reducing the noise caused by false positives and allowing security teams to concentrate on genuine threats. For example, Splunk, a widely used SIEM platform, has incorporated AI and machine learning features to improve anomaly detection and response times. Another critical aspect of designing AI-augmented SOC architectures is the implementation of endpoint detection and response solutions. AI-driven EDR tools continuously monitor endpoints to detect suspicious activities and potential breaches. These tools use behavioral analysis and threat intelligence to identify and respond to threats that traditional antivirus solutions might miss. For instance, CrowdStrike Falcon employs AI to analyze billions of events in real time, providing rapid detection and automated responses to threats across all endpoints. Frameworks, such as the MITRE ATT&CK framework, can be instrumental in guiding the integration of AI into SOC operations. The MITRE ATT&CK framework provides a comprehensive matrix of threat tactics and techniques observed in real-world cyber incidents. By mapping AI-driven SOC capabilities to the MITRE ATT&CK framework, security teams can identify gaps in their threat detection and response strategies, ensuring that AI tools are effectively utilized to cover all potential attack vectors. To illustrate the effectiveness of AI-augmented SOCs, consider the case study of a global financial institution that implemented AI-driven automation to enhance its cybersecurity posture. By integrating machine learning algorithms into its SOC processes, the institution was able to reduce incident response times by 60% and decrease the number of false positives by 75%. This improvement not only enhanced the institution's ability to protect sensitive data, but also significantly reduced the workload on its security team, allowing them to focus on strategic initiatives. Despite the benefits, integrating AI into SOCs presents certain challenges that must be addressed. One of the primary concerns is the risk of algorithmic bias, which can lead to inaccuracies in threat detection and response. To mitigate this risk, it is essential to ensure that AI models are trained on diverse datasets that represent a wide range of scenarios and threat types. Continuous monitoring and updating of AI models are also crucial to maintain their accuracy and relevance over time. Moreover, the successful implementation of AI-augmented SOCs requires a skilled workforce capable of managing and optimizing AI technologies. This need highlights the importance of training and upskilling security professionals to work effectively with AI tools. Organizations should invest in cybersecurity training programs that focus on AI and machine learning applications, ensuring that their teams are equipped with the necessary skills to leverage AI technologies in their day-to-day operations. In conclusion, designing AI-augmented SOC architectures involves a strategic approach to integrating AI technologies into security operations. By leveraging AI-driven tools such as SIEM systems, EDR solutions, and frameworks like MITRE ATT&CK, organizations can enhance their threat detection and response capabilities, improving overall security effectiveness. However, it is essential to address challenges such as algorithmic bias and the need for skilled personnel to ensure the successful implementation of AI in SOCs. By doing so, organizations can build a robust cybersecurity infrastructure capable of defending against the ever-evolving threat landscape.